Jensen recently gave an interview with an old Trier podcast, and he said something I want to discuss a bit more. He said that if self-driving car technology had been only started 3 years ago, most companies would be on the right path. In other words, he's implying that a lot of work has been done without the knowledge that we have now, and that now we're much faster. So he's making a few implications here. One is that a lot of the knowledge of the people who've been working before is not obsolete, but just they're trying to solve problems that can be solved much easier. And then second, he's also, I guess, putting himself in a position where he can say, look, I'm a bit late to the party, but I have all the tools that are needed to succeed because the technology is there. What he's saying here is really interesting for several reasons. I mean, in technology, you are usually running up against exactly that type of problem, which is that you do something and then you build a stack, and then lo and behold, that stack is obsolete because some new technology has come along. And the perfect example actually is Tesla here. Tesla has started about 10 years after the first self-driving car pioneers around Sebastian Thrun and many others, but he's sort of the most famous one with Google because they won the DARPA challenge. They started in the early noughties, and so the 2000s, and the computer vision, neural networks, machine learning, all of these things were in very bad shape back then. In fact, they really weren't existent if you think about it. So what they did is they tried to solve problems with sensors, smart sensors, or the Mobileye area, and many other type of problems were solved back then, particularly again smart sensors. Mobileye became a very interesting company because what they did is they sort of built software into the camera that was able to deterministically figure out what's going on and make decisions based on that. So it was like, to use Jensen's words, a car on rails. It's just digital rails. So those were digital rails. Those weren't rails like the railway rails, but still kind of not really AI like we have it today with Tesla FSD and other endeavors. So then, the ImageNet challenge comes along. AlexNet wins, neural network revolution. We can learn from data. We can have function approximation through data. Software 2.0, Andrej Karpathy comes along. CNN, convolutional neural nets, start dominating computer vision. And lo and behold, we have Tesla and its full self-driving, computer vision-based technology take center stage. And that started in 2015, and it took about 7 years for Tesla to pivot from that to end-to-end learning. Now, that pivot was possible for two reasons. One, the compute, the data was available. They collected enough video data to actually be able to learn from imitation. And second, they had enough compute to train the models, and then also enough inference compute to do the inference. What Tesla was lacking was the decision-making on the spot, the out-of-distribution decision-making. And arguably, they still lack that today, although they've been able to solve that with sheer scale. So what Tesla kind of did here was applying the bitter lesson out of necessity, which is, look, we don't have reasoning, which is the one thing, and I'm going to talk about this a little bit more in the detail, but Jensen actually spoke about this also in the podcast. He said whether Tesla has reasoning or not, that's not so important. In other words, he's saying they don't have reasoning and we have reasoning. And that's what's so strong about Nvidia, and that's arguably true. But let's get back to Tesla. What Tesla is doing is saying, look, We don't have reasoning because when we did end-to-end, reasoning wasn't the thing, right? Reasoning really started about 1.5 years ago to become an actual possibility. Reasoning meaning through the GPT revolution and the possibilities of chain of thought and generally taking more knowledge out of an existing pre-trained model, sequentially making decisions based on what's in front of the model. Like those types of possibilities weren't available to the community prior to maybe 2023. So now they're available, but Tesla has solved that problem by just sheer data and scale. Now, whether they're also using reasoning now, I don't know what the most advanced models of Tesla are doing, but the proof's in the pudding. We just came back from Texas. We rented a Tesla from Turo and had arguably, I think we had hardware 4, I'm not even sure, but the car was definitely better than ours, which is hardware 3. And we're also a pretty avid user of robotaxi, and it's very clear. I mean, this thing is just driving now. It's working. It's full self-driving is working, at least at the level of human driving. Now, we have much more to go. We can have conversations with the car. The car can be much smarter than it is already. In other words, it can take you where you want before you even tell it where you want, because it anticipates what you want. It can also be even more safe. In other words, it can maybe avoid bad weather by anticipating bad weather. Things like that are all possible. So we can add a lot more intelligence to the car. But the driving itself, so when we just compare a human driver with a car driver, the car's driving better and it's solved. So now Jensen is the CEO of Nvidia, and Nvidia wants to play in the self-driving car business. The reason they want to play in that business is because I think the way the industry is seeing the future here is that all of driving will go automated, and with all of driving going automated, we have to the tune of 10 trillion miles driven globally on Earth, and if you take whatever metric you want to use now, 10 cents per mile. I don't know what the average is. It's probably $1 per mile in the US. It's maybe 20 cents per mile in the third world, and dollar everywhere else. I mean, in the first world or something. So I don't know if it's 30 cents, whatever it is. I mean, trillions. And therefore, there's lots and lots and lots of money. It's a huge market. That's why Tesla's market cap is what it is. And I think Nvidia wants a piece of that. So that's why he's entering that market. He's also entering that market because he can, right? Nvidia has all the ingredients. Now, here's my critique about his statement. Because so far, I'm agreeing with him. I think we have much better technology. We're not on rails anymore, like we were under the regime of sort of the Mobileye times, and then definitely also with Waymo. These are cars on rails, digital rails, but still rails. And FSD is an AI in the wild, used in the wild. It's the first robot at scale being used by real customers, and in a general form. That's important. So it's in a general form. So it's not like again, it's not on rails. I can put my car in Shanghai as much as I can in Berlin and in Texas and San Francisco and so on and so forth. So now, having said all of that, what's my critique about Jensen Huang? And I'm really very careful critiquing Jensen Huang. I mean, he's been right so many times. He's created the largest company, so I don't want to critique him. I want to be very careful. And by the way, when I say critique, I don't mean I'm not attacking him or anything. I'm actually a shareholder of Nvidia, so but it's a critique, and I'm sure, knowing his personality, he'd be very open for that critique. And the critique is the following, Jensen. Here's my question to you. Like, let's assume you have access to the training capacity that you have. Let's assume you have access to the models, the vision, language, action models. So that means that you have vision. You've solved for vision. You've solved for language, so you've been able to add semantics to your robot. And let's say you've been able to also translate this into action, so you can actually have a self-driving car. What you don't have, though, is you don't have a sense for what's actually good driving. So what are you actually optimizing for? And you might tell me, maybe you're going to tell me that that's in the language part of the VLA, so the language, so we can basically learn how to drive just from reading all the internet. I would highly contest that. I don't think that anything physical can be learned from reading or watching alone. It has to be trained by actually doing it, and that's what Tesla did. So the big advantage of Tesla and the video data that Tesla has collected during training is not just imitation learning so that the car can learn how to drive, but it's also a benchmark for what actually driving means. See, that's something that we sometimes forget, right? How do we know what's a good poem? Well, GPT has taught us, and Gemini and Grok and Claude and everybody else, Claude less actually, but the others, the general models, they've taught us that we can actually infer what a good poem is just by reading a lot of poems, right? What is a good, public relations statement when you're given a problem? Well, you read millions of public relations statements and then you average out. So you do this, what's called maximum likelihood method in statistics, where you say, okay, given this prompt, in which world where does this belong? What's the most likely, in technical terms, what's the most likely distribution where this belongs to? In more layman terms, is if I give you X, where would you put it? In all the possible arrangements, where does it belong? And what that means is, through next token prediction, the model is able to generate you a really good answer. So given all of that, the idea, I think Jensen's playing with the idea that you can actually learn physics, you can learn driving, you can learn everything just from text. And I don't think that that's true. And I would say he's a bit inconsistent, because when it comes to actual robotics, he's not a big fan of just using language as a sort of benchmark. So the conclusion of this episode is it's a critique on Jensen's comment that had we started 3 years ago, everybody would be at the same level and there's no real advancements. I think Tesla has done it the right way. Whether they've done it the right way by chance or by luck, I don't know. Musk once said that the biggest superpower is luck, and maybe he just got lucky here, because I'm not sure he was that savvy in 2015 when he started his self-driving car endeavor. But clearly he's been able to deliver. I mean, Tesla has delivered full self-driving at scale in general form, and I think they've done it through brute force, without reasoning and all of those things. But it's there, it's working, and it's being criticized, I think, from all angles, because a lot of people are in that business. The car business, the robotics business, the AI business, the AI research community. Everybody has skin in this game, and most people don't like the outcome, because a bunch of people in Palo Alto and Austin and Shanghai and maybe even in Berlin, not really famous people, whether it's Ashok, who doesn't really have a name, still doesn't have a big name in the AI community, if you think about it, which is crazy. You have, people that I respect a lot, whether it's Sergey Levin or Chelsea Finn or people like that. I mean, lots of people who have great names in the robotics community. Then we have, Figure and companies like that, which are going around pretending that they're the best thing since sliced bread, when actually all of these people, at best, have nice prototypes, publish a lot of papers, and make good videos. And here we have a company which has actually physically solved the robotics problem, at least on wheels. Certainly not on the humanoid side, but on wheels they've solved it. I mean, I can't say it enough. And there's, YouTube and X are full of videos and comments of people who have done the same thing, driven thousands and thousands of miles without having actually driven, without touching the steering wheel, because the car has done it. And at this point, I can tell you I can, drive through San Francisco, and I'm absolutely happy to check my phone and read something or watch a video while I'm driving if I was allowed to do it. I'm not doing it because I'm not allowed to, but I'd be I wouldn't have one hesitation to do it because it's safe. It's that good. And again, like maybe you need a few tweaks here and there, so it's still good to have access to steering wheel. Just if the car gets stuck somewhere. I mean, there are edge cases, but any edge case, in my opinion, that I have witnessed has always been about me not annoying the people around me. It wasn't about safety. It was just that maybe it took a bit too long to make a right turn on red, or maybe it confused three different colors of lamps, showing you can go, you cannot go. I don't know, stuff that's confusing even for humans, so you kind of have to tiptoe your way around. Those types of situations that a robotaxi, which is unsupervised, could still solve by just going to the side and wait till everybody's passed and then just go, or things like that. So anyway, conclusion. What's my conclusion here? My conclusion is that sometimes in technology, yes, you can be too early because you just don't know what the knowledge will be, but you have to start somewhere. And I think to say that had we started 3 years ago, we all be at the same level now is a little bit disingenuous by Jensen. I think second, he's right in the sense that yes, sometimes, particularly in AI, which goes so fast, we can do things that can become obsolete just because technology overrides it. That's true. And we've seen that in self-driving. But I think third, most importantly, I think Tesla deserves a lot more credit than they get in the press and in academia, because they really have solved the robotics problem on wheels. And I think they got lucky. They got lucky. They got lucky because their approach would not have worked if it hadn't been for the massive amounts of compute and data and video collection capabilities that they've built. So I guess they got lucky, but they also deserved to get lucky. And I guess luck is just simply the preparation and to be ready to strike when the opportunity shows. Because what Tesla did, and kudos to Musk, they invested a lot of money in training when that wasn't as obvious. They invested a lot of money in inference when it wasn't as obvious. And they invested a lot of money in video and data collection when it wasn't as obvious. Thank you.